It would be my pleasure. Before I get into the specifics about Angela, I would like to kind of tell I got uh, involved Zoological Museum. I had the good fortune about 3 years ago of taking a tour of the museum in their old location. And to put it bluntly, it was like walking into a closet. There were cabinets to the ceiling. You could barely walk down the aisles, but that's okay because the whole room, and it was a fairly large room, was stuffed to the gills with all of hundreds, I'm sure thousands of objects from the natural world that are there for the research and study of students and faculty. And I came aware of them a couple of years ago when I had an exhibit of mine on Western wildlife at the Montana Museum of Art and Culture, and the Wright Zoological Museum kindly loaned five three-dimensional objects to go with my two-dimensional engravings. They were kind enough to loan a head of a bighorn sheep with big curls, a grizzly bear skull, a bison head, an osprey, and a live, I'm sorry, a full-size, yeah, a live one, a full-size taxidermy specimen of a wolverine, and it added a lot to my exhibit. So joining Senior Forum, I began thinking of the people I knew that might be able to come to our organization and explain their circumstance. So a few months back, I met Dr. Angela Hornsby up in their new building. Angela, can you say what is the name of your building? I've forgotten.
So the new building is the Interdisciplinary Sciences Building.
Okay, it's on the south end of campus. She's up near, I think it's, is it the third or the fourth floor?
Yep, third floor.
I'm
on the third floor, but the museum collection's on the fourth floor.
That's why I thought the third and fourth floor, I guess.
Yeah.
So anyway, here is what I asked her to give a little biographical summary. Here's what she sent me. Dr. Angela Hornsby is the curator of the Philip L. Wright Zoological Museum, and we're going to learn about the museum's history, its mission, and exciting new projects and programs under development. With over 23,000 specimens, the Phil Wright Museum is a premier source of vertebrate biodiversity information in the Northern Rocky Mountains, and it supports a wide variety of research, education, and outreach in Montana and beyond. So with that introduction, Angela, the screen is all yours.
Great. So let's see if I can successfully share this. Okay, does that look right to you guys? As far as you know.
Yeah, that looks fine, Angela.
Okay, great. So first of all, thanks to Lee and Jim for inviting me and helping me get set up here. Of course, it would be nice to meet all of you in person and get to talk in person. But I'm glad that we have this alternate, forum where we can actually still connect in some way. So I'm excited to tell you a little bit more about the museum. And yeah, we'll get going. So let me just fix this up a minute. Okay. Most of you probably are familiar with natural history museums as public places where you can go and look at displays and learn about natural history from basically like displays and things that are geared towards public education and outreach. This is a picture, for instance, of the Field Museum in Chicago. And I love big institutions like this. I think that they're amazing, and I love all that public outreach stuff. But what most people don't realize is that behind the doors of all of these big museums, almost all of them also have back rooms for research where they house thousands and sometimes millions of specimens, especially if you're studying really small things like insects, then you have millions and millions of specimens in your back rooms. And these specimens are used for all sorts of types of research. And really, when I think about museums and the museum back rooms where the research happens, I think the big underappreciated fact is that museums are the heart of our understanding of biodiversity. So anytime a new species is described, almost without fail, it's very rare for a species to not be described in reference to what we already have in museums. So sometimes, once in a while, you'll hear a story about someone who is in the field and happens upon a frog that they've never seen before and they can't find in their field guide, and they say, "Oh my gosh, it's a new species." More often than not, far more often than not, someone will collect a specimen in the field, bring it back to a museum, compare it to what we already had, and realize, oh, this is something different. We can differentiate it morphologically or genetically, or maybe it just stands out in a way and we need to go do some more collections to figure out if this was just an odd specimen or if there actually might be some other species out there that we haven't recognized before. So when you're thinking about all animals, all plants, and all multicellular fungi, basically, if a species has been described, there's almost certainly what's called a type specimen somewhere in a museum that represents the first record of that species, the first description of that species, and that's the reference to which all new specimens are compared. But the power of natural history collections goes far beyond just understanding biodiversity patterns, even though that's a big deal in my opinion. We use the collections to ask all sorts of questions about how organisms are related, evolution and adaptation. For instance, here in Montana, there's a researcher who's working on coat color adaptation in snowshoe hares and the timing of that and the geographic variation in that. We're using specimens to understand climate change over the last 100 to 150 years, especially. Using specimens to understand land use changes and fire regime changes, which are going to be really important in Montana in particular. We use specimens to understand the effects of environmental toxins. So this is a cool one. Probably most of you have heard of the pesticide DDT that was used really commonly in the 1960s and 70s. And the problem with DDT is that when it gets into the diets of birds through their prey, it ends up affecting the amount of calcium that's deposited in their eggshells, and the eggshells become really thin and more prone to break when the bird is just incubating their egg like usual. And the reason that we were able to identify that eggshell thinning was the problem was by looking at eggs that were collected before and after DDT use. And another one, I actually had this in this slide far before this became an issue recently, but emerging diseases. Especially if there's a pathogen that has a reservoir in an animal population somewhere, having some specimens of that population, of that animal or species, is really useful in being able to trace where these diseases come from, what other diseases might be in animal populations that might be transferable to humans. So even before the coronavirus arose, museum collections were used to identify, for instance, the reservoirs of hantavirus, which is pretty common out west, and also causes a respiratory disease. So all these uses and more. We have the fun thing about natural history collections is that you never quite know what they're going to be used for. And that kind of brings me to the museum ethos. So this was really developed by several people, but the person who formalized it, in print at least, was Joseph Grinnell, who was the curator at the Museum of Vertebrate Zoology at UC Berkeley. And he was working in the early 1900s in particular. And he was the first one to kind of put down on paper the understanding that we were collecting things often for our own research, but also for the research of people who would come after us. So kind of paying that opportunity forward. So the way that he described this, even just sort of like informally in his writing, is at this point I wish to emphasize what I believe will ultimately prove to be the greatest value of our museum. And in this case, he was talking about the museum at UC Berkeley. This value will not, however, be realized until the lapse of many years, possibly a century, providing that our material is safely preserved. And this is that the student of the future will have access to the original record of faunal conditions wherever we now work. And even by the time Grinnell was working, they weren't.
It's just hard to believe that they're pushing for these kind of things. When Nancy Pelosi makes it a national issue, all she does is slow down the inevitable. It's going to inevitably be a tough process anyway when you get a fourth phase of funding done. Yeah. It's just not going to get finished. That's on the federal level. You mentioned California. Here's our attorney for the Center for American Liberty going after Gavin Newsom, saying that he's got $75 million.
I'm trying to figure out who's muted.
It's noisy over there.
Unemployment, housing issues, business closures, and massive limitations on.
Yeah, I think if you're just make sure everybody that you're muted. There we go. Okay.
Okay.
So this is really the ethos of the modern museum. This was the thinking that took museums from sort of like the cabinets of curiosity where, oh, here's an interesting specimen from far away, into the thinking that museums are these useful repositories of information that we can use to learn about the world and ask scientific questions from. So this is really the ethos that modern museums follow today, modern research museums. And the fun thing, I think, is that I don't know what the questions that our students of the future will have or what technologies will be available to them. For instance, when Grinnell was working, they knew that DNA existed, but they didn't know the structure. They had no idea that it was the molecule of inheritance of information. So thinking, 100 years later, we have all this technology to be able to do things with these specimens that they couldn't have even conceived of. And I like to think 100 years from now, our students of the future will be in the same relative place that we are now. So understanding that, we do our best with our limited resources and time, as always, to preserve what we think might be the most important to describe our world as we see it today and as it changes through time. And really the power of natural history collections comes from the accumulation of specimens through space and time. So people often ask me, why do you need, 2,000 specimens of a deer mouse or something? And frankly, the more specimens we have, the more information we have, and the more power we have to ask interesting questions. And this extends not just through our collections here, but in the whole network of museum collections throughout the world. The museums, we all work really closely together, figuring out the best way to curate our specimens and figuring out how to share our information and to facilitate research. So with that, I'm going to tell you now specifically about the Phil Wright Museum here on our campus. First off, our really basic mission is to curate and grow the zoological collections for use in research, education, and outreach in Montana and beyond. And in doing so, to provide a variety of opportunities for students to work with and learn from natural history collections. And that second part actually isn't formally part of our mission, but that's kind of my own personal mission. In addition to making sure the museum runs as it should, I'm just really invested in making sure that I can get students into the museum in as many capacities as possible. A little bit of our history. So we were founded by Morton Elrod, who was the first biology prof at UM. And in fact, our collection, the Zoology Museum, is only 4 years younger than the university itself. So we were founded in 1897. The university was founded in 1893. And 1897 was actually the year that Morton Elrod started at the university. So he basically, as soon as he appeared, started the Zoological Museum. And he started it actually with a whole bunch of specimens that he had brought with him from the East. So the majority of our really old specimens, like from the late 1800s, are actually from like Illinois and Indiana. But as soon as he got to Montana, he started collecting here as well. So we have some really old specimens from his time. If you might have heard the name Morton Elrod, he really was foundational in a lot of things that happen in this area. Another one was he founded the biostation at Flathead Lake, where researchers still work today. And just another fun fact about our museum, where the Zoological Museum and actually the Paleontology Center, also on campus, are so old that we were actually housed in the original just main campus building, which still stands today at the top of the quad. So like I said, some of our oldest specimens are from Morton Elrod, and you can see this is one from Flathead Lake in 1900. And this is a silver-haired bat specimen. So around the 1930s to 1980s is when Phil Wright became the curator of the museum. And he was really foundational in making the museum what it is today. He grew it to over 20,000 specimens, the vast majority of which either he or his students collected specifically for their research. So Phil Wright really kind of brought us into that modern museum ethos of collecting for research and collecting to basically catalog what the world looks like. We focus primarily on birds and mammals and on Montana and the Northern Rocky Mountains. And with about currently 23 or 24,000 specimens, we're not a very big museum, but we have specimens from places that other museums don't. So we have a really great record of the natural history patterns in our area, and we can complement the big museums by filling in some of the gaps in areas that they haven't collected. And because of all of his hard work, the museum was named in honor of Phil Wright when he passed away in 1991. So some quick by the numbers. So we have about 14,500 mammal specimens, more than 7,000 bird specimens from over 100 families. We have several dozen specimens of fish and amphibians and reptiles, but we actually moved most of our fish collection to another museum that was able to curate it better than we could at the time. Our specimens come from mostly Montana and North America, 15,000 from Montana and 20,000 overall from North America. But due to some really cool specimen exchanges that we did in the 1970s, we have about 500 specimens from Asia and around 300 from South America. And we have some really cool stuff that a few species that are really rare in museum collections and are only found in a few museums in the world. So those are some really fun and precious specimens for us to have. And as Lee alluded to, our big project over the last few years has been the renovation. So I think actually the best way for me to explain to you what we do and what that looks like is to just kind of show you what the renovation has looked like and what our new spaces are looking like and functioning like. But before I get into that, I do want to acknowledge that the support, the funding for this renovation came from the Friends of the Museum, which is a group of donors that's been really wonderful over the years, the UM Division of Biological Sciences, the UM Office of Research and Creative Scholarship, and the National Science Foundation that recognized that we were a collection in need of some money in order to stay afloat. So they gave us a collections improvement grant that was enormous. So yeah, we'll just go on a virtual tour now. So the museum currently lives in 2 different buildings. As Lee alluded to, one of those buildings is the new Interdisciplinary Sciences building, which I'll show you at the end. But the first building that we still have a lot of space in is the Health Sciences building, which was built, I believe, in 1964 or so. So we have, I guess, 5 rooms technically in Health Sciences. So I'll just step you through what those each look like. The first one is the classroom. And again, as Lee mentioned, this room was historically the sole room that the museum was stuffed into. And stuffed is really the right word. It was absolutely filled from bottom to top, such that there was hardly even any room. You can see on the right that the students crowded in. There was hardly any room to spread out projects and work on things, especially if someone else was going to be involved. In addition to just the crowding, which made it hard for the museum to grow, all the cabinets were quite old, and that became a preservation concern because the cabinets weren't very well sealed. You can see even some of them are wood, and wood is pretty easy for pests to penetrate. So there are bugs that specialize on dried skin, and so the museum is just like a buffet for them. So they were getting pest infestations in these cabinets pretty regularly, which is obviously a hazard to the specimens and also a hazard to the workers because it creates a lot of dust and then requires us to use chemicals to tamp down the pest infestation. So it was a wonderful collection, and it was just in absolutely dire need of some facilities upgrades. So we actually took that room and completely gutted it and changed its function. So this is now the new classroom. This is what it looked like during our renovation. And this is what it looks like today. And this is the classroom that supports the mammalogy teaching labs, the ornithology teaching labs, as well as a whole bunch of outreach programs that we put together and that we run with the Montana Natural History Center. And this is kind of an open space that we're working to bring other groups in, especially during the summer, just because it's flexible, it has some displays in the back about natural history, and it just is a nice way to bring people onto campus and let them use this resource that we've developed. So off of that classroom, conveniently now, is our storage closet where we keep all of the collections for teaching and outreach. So the specimens that don't have really great data to go along with them are the ones that we're willing to let a bunch of 5-year-olds handle. I don't have a picture of the storage room yet. I need to get one, but our cold room is kept at about 60 degrees and pretty low humidity, and this is where we store all of our pellets. And it's pretty crowded, as you can see. We're actually working right now to get that all cleaned out and organized better. Across the hall is our new skull storage room. And previously, this was the classroom before we moved the classroom across the hall. And it was functional, but we ended up realizing that it would work better as a storage room for us. So again, we gutted this all the way back down through to the subfloor. And we have re-engineered it now as our skull storage room. And you can see there's nothing in there right now. We're actually in the process of moving all of our big, bulky skulls and skeletons into this room. And it's easier to store them in these kinds of shelves where you can move things around and let them spread out as needed instead of in the cabinets. This room is also going to be kind of our project room, where anything that's coming in or out of the museum, whether that's a new accession or a loan or just a project that a student's working on, they'll have space in this room to sort of spread out and work on that. Right next door to the skull storage room is our prep lab. And the prep lab hasn't changed very much. Actually, the major change is this freezer that you see right there, that's a -80 Celsius freezer, which is a lab grade freezer for storing all of our DNA and tissue samples from the specimens we collect. So pretty basic prep room. This is where all of the dirty work happens. And on a typical Friday afternoon, at least before we had to shut campus down, we would have 3 or 4 people usually in the prep lab working on specimens, just trying to clean our freezer out and make some more room. And we have a domestic colony. So this is a beetle colony, the larvae of which like to eat the dried flesh. So when we, we'll go back here. So when we prepare a specimen, we'll skin it fully, and we'll stuff the skin with cotton and put wire in the limbs to reinforce them. And that will just dry out and preserve naturally. And then the skeleton and the skull, we'll take as much tissue off as we can, but then the rest of it will go into the beetle colony, and the beetles will eat all of the extra tissue off, but they won't touch the bone. And the smallest larvae are only a few millimeters long, so they're really good at getting in and doing all the detail work of cleaning off the skulls and skeletons. So then that brings us to the second building, which is the ISB, Interdisciplinary Sciences, and the last room, which is our archival research collections. And this really is the heart of the museum. This is the big, exciting part of our renovation as far as we're concerned. So before, actually, this room wasn't even complete. The building was so new that they hadn't finished these upper levels yet. So it was part of our fundraising with the Friends of the Museum and with National Science Foundation was to just complete the basic build out of this room, as well as obviously to get all the equipment in. So that was the before, and this is the after. So now we actually have workspaces where we can spread out and work on projects. We have enough bench space for a couple computers, obviously, for some imaging equipment. We have a camera setup that we're working on right now. So all the basic stuff that we need as a natural history museum to function. And then the really great part about this room is the new cabinet system. So these are pretty standard metal, all metal cabinets, and they're really well sealed. But the special thing on the left, actually in both photos you can see, is that the banks of cabinets are on electronic tracks. So in order to maximize the space, the storage space in the room, that we can slide each of the banks of cabinets down and basically make a walkway wherever we need it in between the cabinet banks. So that whole row that you see on the right of cabinets will move down, and there's about 5 other rows that can also move down and make that walkway wherever we need it. So that's what it looks like usually on the left. Everything's closed up, and then on the right you can see this is part of our bird collection with some of the trays pulled out. So this is where our around 22,000 or so specimens live, and I love bringing people into this room because it's just sort of endless. You could stay in there for hours pulling out drawers and looking at all the cool stuff that we have. But we have an awful lot of birds. Again, we have a mix mostly from Montana, but some, as you can see in there, some exotic things. These are some northern pygmy owls, some Steller's jays, and these are scientific preparations. So they're not meant to look lifelike. In fact, they're meant to do 2 things. They're meant to display for us the characteristics of that species that are most important for identifying it and comparing it to others. And also, it's meant to just fit in the drawer compactly. So we're always trying to maximize our storage space, and part of that is making sure that we're packing the specimens in the best way that we can. These are some other specimens. Actually, that's one of my favorites. Right in the front there is a bird of paradise specimen, and we have some other cool exotic things. This is a king penguin specimen, so that's always a fun one to show people. We also have a really nice collection of bird nests and eggs, and these are among some of our oldest specimens. For instance, this is a redstart nest from 1901. And we have a kingbird nest from 1962 and a set of bobwhite eggs from 1894. So some really cool old stuff that we've been able to take good care of. And of course, we have a lot of mammals, and particularly a lot of small mammals, because most mammals are small. We have tray after tray after tray of bats, and on the right are a bunch of shrew skulls and vials. We have a lot of rodents. This is the rodent that I worked on for my dissertation work. It's called the bushy-tailed wood rat. And every single one of the specimens that you're seeing here has a tag on it. And that tag has all the information we have from that specimen. So it's species ID, where it was collected, when it was collected, its museum catalog number, who collected it. On the reverse side of the tag usually would be all the measurement information, reproductive information, all sorts of things in terms of that specimen. Here are some moles. I just love their long claws for digging. One of my favorite cabinets is the porcupine cabinet. And this is the point where I realized if you were on a tour with me and I was opening these cabinets, you would realize that each one had a particular smell. And the porcupine cabinet has a really particular smell. So I don't know if you're missing out necessarily on that, but we don't have smell-o-vision yet. And that might actually be a good thing. And of course, we have a lot of skulls and skeletons too. So if you're familiar with John and Frank Craighead, who were bear biologists who worked in Yellowstone area in sort of the 60s to the 90s or so, they did some really foundational work on grizzly bears and black bears. And we have from them a lot of skulls of bears that were part of their studies. So that's a really, really special collection of skulls. And of course, we have a few exotic things too. These are some dolphin and porpoise skulls. And that black piece at the bottom of the drawer is a piece of baleen, whale baleen. And like I said, we sent most of our alcohol specimens to another institution, but we do have a couple cabinets left, particularly of things that are from Montana. So we have a number of snakes and turtles and lizards and even some birds and mammals that are preserved in alcohol. And one of the other fun things that I realized is we had just a lot of old research material. So we have a lot of old slides, a lot of old photo negatives, a lot of old notes and paperwork. And I've had fun starting to sort through all that, and I'm looking for students who are interested in biology, but also history, to help me figure out if any of this stuff has research value or if it's just sort of like fun historical value for the museum to have. So with all that background of what our collections look like right now I'm going to spend the rest of the time going through basically how we function in terms of our three central parts of our mission, so research, education, and outreach. From the research end of things, our specimens are now properly stored, and I can't overstate how exciting that is. That is absolutely central to what we do and how we function as a museum. So we're really proud of all the work that's gone into that, and really thankful for the donors and the National Science Foundation that supported that. I was doing this already in the spring, but hopefully in the fall we'll be able to again start training specimens in research, or training students in research grade specimen preparation. And by research grade, I mean what's called holistic specimen collection. And this is something that I didn't develop specifically, but a whole bunch of people across a whole bunch of museums have tried to figure out what's the best way that we can all collectively be collecting specimens so that we can maximize the amount of information and make sure that everyone's doing it consistently enough to develop good data sets. So when we talk about holistic specimen collection, whenever we get a specimen, whether it's a roadkill specimen or if it was something that was collected intentionally for a research project, there's a lot of information that can go along with that and a lot of different materials. So we don't just get a rat. We get a date, a time and a day where that rat was found and a location where it was found. We get perhaps the weather on that particular day and then someone's field notes. We get the vegetation or the ecosystem that that specimen was found in. We get measurements that help us differentiate between species and also help us describe adaptation to different environments. We get samples of DNA and RNA that can be used for analysis later on that we store in our great new -80 C freezer. We comb through the fur and the feathers to try and find ectoparasites, and we save those in alcohol or we freeze them depending on the need. And we'll take the organs out and we'll go through all the gut contents and the heart and the liver and the spleen and look for endoparasites, flukes and flatworms and roundworms. Sometimes we will take a fecal pellet to look at microbiome and to look at diet. So it could be a fecal pellet, or it could just be like a smear of material from inside several parts of the gastrointestinal tract that help us understand what that animal was eating, how its microbiome, so the bacteria and everything inside of it was reacting to that, and again, potentially in the endoparasites. And we also get information like reproduction. So for instance, when you take the uterus out, you can hold it up to the light, and for each placenta that has successfully attached in the uterus, it leaves a scar. So you can count the number of successfully attached placenta and, hopefully infer around the number of pups that animal has had in her lifetime. So tons of information just from a single specimen, and we're really working towards collecting as much of that as possible. And then the other big fun thing as far as our research is concerned is that our specimen catalog is available online. So we are part of this museum consortium called Arctos, and it's a collection management software, but it makes all of our collections public. So anyone, anywhere in the world, for free, without needing to register or anything, can go to Arctos and see all of the specimens that we have. And it's not just ours, there's a lot of institutions that are on Arctos so that all of our data are available together. And there are even other what are called aggregator websites that pull information from several places, including Arctos, to try and just get all of the biodiversity information in the world together in one place. That's pretty daunting. There tends to be different websites for different groups of species just to make it a little bit easier. But we're working towards that goal of having everything interconnected so that if you're looking for, all of the bushy-tailed wood rat specimens in the world, you can find that through a search at one website. And again, most of our specimens are from Montana, you can see, but they are from all over North America and actually the world, but I didn't show the rest of the map there. As far as education goes, our specimens already have been and will continue to be used for lab-based or specimen-based laboratories in mammalogy, ornithology, principles of living systems, and zooarchaeology. We also support wildlife experiential learning internships. So all wildlife students here on campus need to do, I believe, 60 hours of some sort of experiential learning internship. And we support students to come in and do specimen prep or help me catalog things or help me pull loans. And that's a great way for them to learn taxonomy. And I'm also working to develop a summer workshop and a summer field course that we'll be able to offer in the future that both revolve around museum collections, either working in the collection spaces on campus or actually being out in the field collecting new specimens for us. And then as far as outreach, we have a lot of outreach partners. First, we work with We Are Montana in the Classroom to do K through 12 tours on campus. And we also have educational trunks for K through 12 and public use. So people can basically rent a trunk out from us like you were renting a book out of a library. We work really extensively with the Montana Natural History Center. In fact, if you ever go down to their little museum there, most of the specimens that they have, including a lot of the big taxidermied animals, actually belong to the Phil Wright Museum. They're just on permanent loan for display to the Natural History Center. And we also work with Spectrum Discovery Area, which is sort of a hands-on museum for younger kids in particular. And those are, I'll tell you about these two people a little bit more in a minute, but on the left is Justin Ruby and on the right is Nikki Phillips, and they were two of my interns this spring. So lastly, where do students fit into all of this? And my answer is all the above. Again, as much as possible. I try to bring in as many students as possible and as many roles as possible. And I get most excited about putting students into project-based roles because I feel like that provides them some responsibility and independence and some buy-in into what they're doing. I don't like to just say like, okay, come here at Tuesday on 2 o'clock and I'll give you something to do. I prefer to set them up with a project. For instance, I have a student who's working to clean out and organize the pelt room. And that's her special project. And she knows that she can come in on Friday afternoons and pick up where she left off and keep working towards that goal of getting it organized. And I think that's just a lot more engaging. And I think it's a lot more fun for them too. And the volunteers and interns play many roles in the museum. Many of them are in specimen prep. Some of them, again, are helping to catalog or inventory certain collections or rooms. Down in the right-hand corner, Larry's not a student. Larry's just a wonderful volunteer who comes in and works in the prep lab articulating bird skeletons. But he's great to have the students interact with, and he just makes these awesome resources in bird skeletons for us to use for various purposes. And one of the really fun student opportunities that we have going right now are called the Grassley Curiosity Internships. So you may have heard of Emily Grassley. She was a student at UM. She graduated 9 or 10 years ago now. And she was actually an art student, but she started volunteering in the Phil Wright Museum and became totally enchanted with natural history collections. This was not something that she really was familiar with before, but she just absolutely fell in love with it. And when she was still a student here on campus, she started what's called the Brain Scoop. And this is a video series on YouTube. So you can go to YouTube and look up the Brain Scoop and see all of the videos that she's posted about natural history and natural history collections that all started here on campus. You can actually sort her videos from oldest to youngest, and you'll see her videos from 10 years ago when she's walking you through all the old spaces in the Phil Wright Museum. But Emily has done a lot more than just make museum videos here at the Phil Wright Museum. In fact, now she works at the Field Museum in Chicago. And they essentially made this position for her. They saw what she was doing here at the Phil Wright Museum and thought it was so special that they wanted her to come do it at the Field Museum in Chicago instead. So she is formally the Chief Curiosity Correspondent, and she continues to make the outreach videos. And in fact, she's working on a PBS series right now. I think it's a short series. It's 3 or 4 episodes, but that's really exciting. I think that's slated to air this fall. I'll have to check that. So Emily was a huge influence here at the museum, and frankly, she's been just a huge inspiration for a lot of people. So She received an award on campus called the Odyssey of the Stars Award. And when the administrators here asked her what she wanted, basically in celebration of that, she said, "I want you to make more opportunities for students to work in the Phil Wright Museum." So that's exactly what we did. And we made this internship program called the Grassley Curiosity Internships. So this program funds undergrad students from all backgrounds and all majors. So they don't have to be biology, they don't have to be wildlife, they can be from anywhere on campus. And we just want them to pursue a creative project that helps spread appreciation of natural history collections in new and engaging ways. And this is a competitive application process for them. So they apply in the fall, and then we have so far, and we're planning to hopefully continue to fund 2 internships each spring. And I think critically, these are paid positions, and that makes the experience available to a much broader subset of the student population. Some students need to be working to support themselves. The museum is always open to anyone to come volunteer for free, but some students really need that financial support. So making sure that these are paid was really special for us, and we're excited now that we hope effectively that it's available to anyone who's interested. And again, we had 2 interns this spring. Their work was disrupted a little bit by the campus shutdown, but we are pretty much on track to get them both wrapped up in their projects over the next few weeks. So our first intern was Nikki Phillips, and she is articulating a mule deer skeleton that we'll use for outreach in the museum. And not only is she putting the skeleton together, but she's also going to add some straps that will stand in as the muscles and ligaments, so that you'll actually be able to move 2 of the limbs, I think one front limb and one back limb, and see basically how all of the muscles and ligaments and tendons move as the limb moves. And then our second intern is Justin Ruby. And Justin was really excited about outreach applications with museum specimens, but he recognized that most of the time when we use specimens in outreach, we can only show things that are either in poor condition or are really common, because we don't want our really rare and good condition specimens to be manhandled by a bunch of kids and potentially broken. So Justin's idea was to expand what we would be able to use for outreach by 3D scanning and then 3D printing some of our more interesting skulls. So we didn't get to print a lot of his work yet, but you can see here's a couple of captures from the program that he was working in. On top is a sea turtle skull, and on the bottom is a polar bear skull. So basically, he builds these 3D models using photographs, and then this is one that he already completed. Can you see me in the video? Okay. So this is one that he already completed of a small black bear. So this is all plastic, but it's pretty good in terms of the amount of detail that he was able to capture. And since it's plastic, this is perfect to have kids handle. We are not concerned at all if they break this. It's just another $15 or so to print a new one. That said, they are pretty sturdy, so it's impressive. They've been dropped and everything, and no one's broken one yet. But this is a really, really fun thing that is going to expand the number and the types of specimens that we can use for outreach, especially with little kids. So that's what we've been doing so far. So one last slide to tell you a little bit more about our future plans. The really basic thing is definitely the central thing is to continue to care for and grow our collections for scientific uses. The second is to develop education and outreach resources for for our outreach partners and our local and regional communities. And then I'm excited to continue to try and grow funds to support student opportunities, including the Grassley Curiosity internships, but also technical internships and research projects for students, both undergrads and graduate students. And then with that, if you are on Facebook and you want to follow us, we're on there, and we like to post about the work that we're doing, and also the cool specimens that I run into when I have to do just like pest checks every once in a while. So I like to take photos, like zoom in on feathers and fur and whatnot, or tell a little story about the specimens that we're working on that week. And then, truly, finally, our work continues. We have so much to continue to do, but so many people who are invested in what we're doing and are excited to help. So this is just a handful of people who have been helpful in the last few years, but our history goes back much further, and we have a whole community of people who are excited to see us continue to grow. So yeah, I think with that, we can probably unmute if anyone has questions, right?
Yeah, maybe you could close your screen there so we can get back to the gallery view of pictures. And if anyone has a question, please. Okay, Sandy?
I have met Emily, and her talk is on YouTube of what she did when she talked to the youth. She came back a year later and gave a talk on her her trajectory, and it was amazing because she filled the ballroom. I had not a clue who I was coming to hear, but lots of people already knew her. And so I just wanted people to know you could meet her too on YouTube. And I wanted to ask Angela, could you tell us about the 2 new students you might have chosen this spring for Emily's internship?
Well, the ones I told you about, Nikki and Justin, they were the ones who were working this spring.
Oh, okay.
So spring 2021, the applications will be open this fall for those internships.
Thank you.
Yeah.
Okay, any other questions? Maritza? I see you, Monty.
Yeah, my son and I are wondering how you collect specimens now, and if they're not roadkill, how do you kill them?
Yeah, so that's a sensitive topic, but very fair. So currently, we still get most of our specimens either from roadkill or from window strikes, like birds that run into windows. So that's really good. If an animal dies on accident, we can still take it and use it for research. But yes, sometimes people do go in the field and collect things intentionally. So they'll use nets, or if it's birds or bats, or they'll use traps if it's mammals. And all of that is regulated by what's called the Institutional Animal Care and Use Committee on campus. So it's basically the university's ethics board. So when someone's working in the field collecting, they have to, before they're allowed to do that, they have to write to the ethics board and explain, this is what we're planning on doing, this is how many animals we want to collect, and this is why we want to collect them, and this is why we have to collect the whole animal to get the information we want. And then in terms of like the actual euthanization, that's also regulated by basically the organismal professional working groups. So basically the national clubs or national societies that work on different organisms, they develop the method that they think is the most humane. So for instance, for birds and mammals, what we use nowadays it's called isoflurane, and it's basically if you were taking your dog to the vet and the dog needed to go under for like surgery just temporarily, they would use isoflurane to knock the dog out. And basically in the field, what we do is just overdose with isoflurane. We just leave them, with this isoflurane
for a longer period of time. So basically they pass out right away, they don't feel anything, they hopefully aren't scared, and we think that's the most humane way to do it.
So we get a lot of bird strikes at our house, and we try to save most of them, and we are pretty successful. But if we don't, would you like those specimens?
The short answer is yes. So, so the short answer is yes, and the long answer is yes, especially if you write down the information that you have for that animal. So like when you collected it, when you think it died, how it died, all that kind of stuff, your contact information. If you write it on a piece of paper and freeze the animal in your freezer, then basically the next time you're on campus, you can, or over in this area, you can drop it off at the museum, and then it'll become part of our collections.
Okay, Monty? You gotta unmute yourself, Monty. Monty, are you on a computer or an iPad? If you're on a computer, it's lower left-hand corner. If you're on an iPad, it's upper right-hand corner. Does anyone else have a question while Monty's trying to figure out how to unmute himself? Sandy again?
When it's safe to come out, can you tell us how easy it is to get a tour?
So I would be your tour guide, so all you have to do is email me if you're interested. And I most enjoy giving tours to groups of people. I will occasionally give a tour if it's just one person, but I think it's more fun if it's a group of people, and it's just more time effective if there's several people who are interested.
Sandy,
Thank you.
We'll go with you, Sandy.
Okay, Monty,
Okay, am I on?
you're on now.
Okay. I'm reading a book called Spillover right now.
Mm-hmm.
The author is from Montana, in fact, and it's a New York Times bestseller. It's called Spillover: Animal Infections and the Next Human Pandemic. And anyway, the first story that he writes about, he travels all over the world and goes into the bush with gorillas and wherever there's a outbreak. And it's really interesting. However, the very first story of his happened to be in Australia, and it was retired racehorses. And all of a sudden they started dying, and they had a bunch of detectives go over there and to see if they could find out what was the cause of the deaths of those horses all of a sudden. And so I'm wondering that your place there, your museum, does that get questions from people like this that go out into the bush and say Ebola from the gorillas or whatever? Do they contact people like you and your entity to get further information from your storage or whatever for DNA and that kind of thing?
Yeah, definitely. Our collection wouldn't be relevant for, for people who are working in Australia, because we don't have much from Australia. But there are museums in Australia that specialize on their species.
Sure.
Yeah, so definitely. I think that's actually, whenever there's a new emerging disease that appears to have come from, wildlife,
Mm-hmm.
I think that's one of our first instincts now, is to ask, where have we, in what other species have we seen something that's similar to that? And if you can start to narrow down, like, oh, maybe it's this particular family of bats or thing, then people start going into their collections and going back to their their DNA or their tissue samples and seeing if they can find that bug in there. Yeah.
Well, as they found out, these horses were congregating under trees, and there happened to be a bunch of bat colonies in those trees, and the droppings from the bats onto the horses under the ground and being trampled and turned into dust caused that disease, that horse disease, called Hendria or something. Anyway, I thought it was interesting. Thank you.
Yeah, thank you.
Jim Harmon?
I was just curious why I missed writing it down, but the critter you studied for your thesis, if it had an interesting name, tell me a little bit more about, is that a Montana critter?
Oh yes, so bushy-tailed wood rat. So that species found from about northern Arizona up to Alaska. And it's a mountain specialist. So the genus Neotoma has about 25 species, and most of them live in like the desert Southwest. But this one species, the bushy-tailed wood rat, sort of like went its own route and specialized in like cold and mountainous areas. So it is really common in Montana. And actually the type specimen, the very first specimen that was used to describe the species is from Great Falls, Montana. And one of the really fun things about, I'll talk about bushy-tailed wood rats for 3 hours, so you'll have to cut me off. But one of the really fun things about bushy-tailed wood rats is they build what are called middens. So basically they live in the rocks and they build their houses out of sticks and stuff, and their houses are really tidy. They'll have different chambers for sleeping and storing their food, and yeah, I think several chambers for sleeping. So their house is really tidy, but then usually next to or on top of the house, they'll build what's called a midden. And this is just their refuse pile. This is stuff they just drag in from the environment, like bones and teeth and plant fragments, and they like shiny things and newspaper fragments, anything that they can find that is interesting to them, basically. They'll put on the midden, and then they'll poop on it and they'll pee on it. And they do that year after year. And wood rat after wood rat, generations will live in the same house and keep adding to the same midden. And those middens in areas where they dry out instead of rot will last for at least 40,000 years. And 40,000 years gets us back beyond the last glacial maximum, which was 21,000 years ago. So that's when we're talking about 21,000 years ago is like the time of like mammoths and giant ground sloths in North America. So these middens that the wood rats build give us this record of especially vegetation change through the last 40,000 years.
Okay, anyone else? Lee?
Angela, that was a very professional presentation. I'm very impressed. And I want to say you've educated me a lot, because the last time I was in your facility is at the old place. And you've certainly made a great leap forward into more modern and useful circumstances. My particular question is, how does your collection and the people that do the research filter their information out to the general public so that people can see that the plant and animals around us have something to say about the impact of humans in the Anthropocene?
Yeah, that's a great question, and it's one that we grapple with because we spend so much time sort of like zooming in and worrying about the scientific particulars of what we're doing. And we know it's important to zoom back out and explain to everyone what we're doing and what it means. But I think that's where, well, we either usually don't have much time or we're not sure the most effective way to do that. So that's one of the things that I'm trying to do in the museum, is to be a little bit of a facilitator for people who are doing specimen-based research on campus. I'm trying to help them translate what they're doing into education and outreach modules that can be used either for like university level or K through 12 education, or that could be used for other events, you know, like the senior here. So the answer to that is we want to do better, and we're working on it. Yeah, there are labs that do a lot of outreach and do a lot of tours. And at this point, it's still just kind of piecemeal. So that's why we're trying to work a little bit more with We Are Montana, because they're the campus group that I think is going to help us bring more people on, or connect us to more people that might need to hear that information.
And how does your museum compare to facilities in other universities throughout, say, the Northwest or the American West?
Mm-hmm. I would say now that our renovation is done, I would say in quality we are on par. In size, we're quite small.
Okay.
The really big museums on the West Coast, for instance, are the Burke Museum at the University of Washington, California Academy of Sciences in San Francisco, and the Museum of Vertebrate Zoology in Berkeley. And there's also University of New Mexico has a very big museum. So those museums are easily 20 times our size, but they also have 20 times our staff, and 20 times the number of faculty who are doing specimen-based research and are adding specimens to the museum and bringing money in to support the museum. So we're a pretty small operation, but like I said earlier, we have a core group of people here who are doing specimen-based research, and we're working in areas where those other museums and those other personnel aren't working. So even though we're small, we truly are filling in this area of the world, and I think we're doing a really good job at it, so that other museums recognize, like, we don't need to spend a lot of time and energy in Montana and in the Northern Rockies, because the Phil Wright Museum is being active there.
Jack? You have to unmute yourself. There we go.
Unless there's an unusual feature, do you only collect one of each specimen?
That's a good question. It depends on the goals when you're out in the field. It depends on the goals of your research. I would say usually there are two different ways normally that people will work in the field. They will either be out looking for a particular species that they're working on, or they'll be trying to do a survey or a full inventory of all the species that they can manage to find. And if you're only working on one particular species, then you might say, oh, I only feel like I need 5 or 10 specimens from this location. And if you get more than that, you might let them go. That depends on your experimental design and what the ethics board will allow you to do. If you're doing a survey, where you're trying to get a complete picture of what's out there, then you're going to take everything. And there's two good reasons for that. The first is, obviously you want to know not only what's out there, but also in what proportions, how many of each species. And the other thing is, there are some species that are really trap happy. And if you let that individual go, they will probably come back to your trap night after night after night to get their free meal and then be released. So often for the really rare species, or what we call the trap shy species, you need to get rid of the trap happy ones. You need to trap away the ones that are really, really going to go quickly into your traps, so that the traps will stay open to catch the rare or the more trap shy ones.
Wolf?
Yeah, I was curious. A lot of your students' work and your work seems very hands-on. How has the campus shutdown affected your teaching and the students?
Yeah, to as to the fullest effect possible, basically. So my two interns, Justin and Nikki, because their projects were luckily portable, they could do them anywhere, they were able to keep working. But I had a lot of other students who were doing specimen prep and who were working on various projects that had to be done in person. So all of that had to go on pause. The one thing that we have been able to do, realizing that we couldn't do all of those in-person projects anymore, once the campus shut down, I moved everyone onto a project called georeferencing. So this is maybe a little bit esoteric, but it's really important. So for all of our old specimens in particular, we don't have latitude, longitude coordinates that help us map things really easily. Instead, all we have is on the tag the description of where that specimen came from. So that's good, that's useful information, but it's not mappable information. So what we're doing right now is everyone's working from home in our database, going and finding those specimens that only have the locality description, and we're using a software called Geolocate that helps us identify, based on that description, what the latitude, longitude coordinates are, and also what our uncertainty around the coordinates are. Those historical descriptions sometimes just say Flathead Lake, but we don't know exactly where in Flathead Lake. So we might say, okay, our latitude longitude coordinates are right in the middle of Flathead Lake, but our uncertainty encompasses the entire lake because we know it's somewhere in that circle, but we don't know exactly. So that's kind of, it's not as fun as the hands-on projects, but it's really important, and that's going to help other researchers find our specimens. Often people will do a search for all the specimens in all the museums that meet the criteria they are interested in, and they'll put them on a map and choose based on the map which specimens they want to use for their work. And if our specimens aren't showing up on the map, then they don't realize that they're available. So it's less exciting, but a really important project.
Angela, thank you very much. We've kept you beyond.
Oh, it's been fun.
If you want to stay on for a while, I see that there's some more questions.
I'm happy to take more questions.
Okay, great. Sandy?
Are you back on campus?
So I'm back on campus twice a week just to do pest checks and to make sure that everything is okay and safe. But no one else is on campus right now. It's still just like essential workers.
Kathy, you having trouble seeing the screen?
Just have two bucks walking across our yard.
Oh. Okay, well, Angela, thank you very, very much.
Yeah, thank you.
Very well organized, very informative.
Thank you.